The Wein bridge oscillator is a type of oscillator circuit that uses a bridge network to provide feedback for sustaining oscillations. It is commonly used in audio frequency applications. Let's break down the information provided. 1. Positive power supply startup slope. The startup of the oscillator is dependent on the positive power supply's startup slope. This implies that the oscillator relies on a changing voltage in the positive power supply to initiate the oscillation process. 2. Slew rate of power supply. The oscillator might face issues if the power supply doesn't change voltage quickly enough. The slew rate is the rate at which the voltage of the power supply changes. If it's too slow, the oscillator might not start. Increasing R3 can help by increasing the gain and improving the likelihood of starting. However, it's noted that this can also increase distortion as the amplitude approaches the power supply rails. 3. R3 adjustment. R3 is a resistor in the circuit, and increasing its value increases the gain of the oscillator. This can help the oscillator start more reliably, but it comes at a cost. Higher gain can lead to increased distortion, especially when the amplitude of the oscillation gets close to the power supply rails. 4. Distortion. Distortion is undesirable in many applications, especially in audio circuits where a clean signal is crucial. The mention of distortion in this context suggests that there is a trade-off between ensuring the oscillator reliably starts and maintaining a low distortion level in the output signal. In summary, adjusting R3 in your Wein bridge oscillator circuit can impact the startup behavior and the distortion of the output signal. There seems to be a balance between reliable startup and acceptable distortion that needs to be considered when designing or optimizing this circuit.